Hello everyone, welcome to network simulation. So today we're going to talk about a network simulation tool named Network Simulator version 3 or ns3. So what is ns3? So ns3, I have told earlier that ns3 is a network simulator tool. So we can simulate different networking protocols using this tool to test out their performances. So it can be used to simulate the network events that happen using the protocols, networking protocols, and we can obtain different network metrics like throughput, delay, packet delivery ratio, etc. So it is widely used by researchers to develop and test new networking protocols. So to learn and experience ns3, we need some prerequisites. So what do we need to install and to learn about ns3? So first, we need some basic Linux skills because ns3 supports only Linux. So if we want to run ns3, we must have basic Linux skills. So, and also we are dealing with networking. So basic networking knowledge is a must. And then also we have to program our simulators, and also if we want to change the protocols, we have to program it accordingly. So basic programming skill is also a must. So ns3 is internally written in C++ to its core. So if we have C++ knowledge, it will be a very helpful for ns3. But we can also run our code in Python. So having a good knowledge in Python will also help us. So how do we install ns3? So first, we go to the nsnam.org. This is the official website for ns3, and download a version of ns3. So we'd like to install the more recent versions, and then it will install an archive. So we will extract the archives, and the extracted folder will look like this. So then we move into the directory, and then we have to install some prerequisites before installing ns3. So we need some packages and libraries which we want to install. So we'll use these Python 3, CMake, Ninja build, and Git. These are the basic libraries that will be needed. We'll install this, and then we'll move into the ns3 directory. So inside the ns3 directory, there will be a couple of folders and files. So we'll talk about that later. So inside this ns3 folder, we will have a program named ns3, which will be used to run our ns3 simulations. So next, as we are going to run our simulation using the Python language, we need a library to support our Python. So we need a special package, Python package named cppyy. But our special warning is that we need to install the exact version, because the latest versions have some problems while running ns3. So we will use this line to install the Python package, and then we will configure the ns3 so that it enables our Python scripting. So we will use ns3 configure and enable Python bindings. Then we will build ns3 and run our first script. So let's go to work, so to build and run our first ns3 script. So here we are in our Ubuntu operating system, and we are inside the ns3 directory. So inside the ns3 directory, we can see that there are a couple of files and folders. So if we want to build ns3, so we just call ns3 space build, and it will build ns3. So as it is already built, so it don't do anything else, but for the first case, it can take some time. So after it is built, so we will use ns3 shell, so that the Python environment of ns3 will work here, and we can run our code in Python. So for our first simulation script, it is located in examples tutorial and first.py. So we will run this first.py script. Okay, so let's run it. So to run it, we can use Python 3 examples tutorial and first.py. It will take some time, but after some time the output will be shown in the terminal. So here the output is generated. We can see some trace of the network events are shown here. Now let's talk about what is happening in the code. So if we open our first.py script, we can see that there are a couple of things for logging. We don't need details for that here. So let's discuss this line. So nodes. So to create a network, we need some devices, right? So this does exactly that. So we need some devices uh, that have some networking capability. So we create two nodes that create two. That means we create two nodes in for this simulation. Now, after creating two nodes, we need to connect them with some kind of channel, right? So we are going to use a point-to-point channel. That means it connects these two devices directly. So we are creating a point-to-point channel using a point-to-point helper. Then we are setting this data rate and delay of the channel. For this case, we are setting the data rate of our point-to-point channel to 5 Mbps and setting the delay of the channel to 2 milliseconds. So if we progress further, we can see that install the we install in the nodes the channel. So okay, that means we connect the channels to the nodes. So if we do that, we get a networking device. That means the net device. So when we want to give networking capability to our uh, computers or devices, we need something called the network interface card. Okay, so the network interface card and their software drivers combinedly enables network connectivity to our devices. So when we attach the point-to-point channel to our nodes, here we get the networking devices. Then we install the network stack to our nodes. That means we tell them to follow a networking stack. That means the layers of our networking. Then we set the IP addresses for the nodes, right? Or for the interfaces. So we have two nodes with each with one interface, and we give an IP address for these two interfaces. So we set the base network address and the subnet mask, and it will automatically set or generate the IP addresses for the nodes. Then we assign the IP addresses to the networking devices or the networking interface card. Then after setting the IP address, we need to set the applications, right? So without application layer, we won't be able to do anything. So in this simulation, we create a simple or basic application for one client and one server. One node will be set as a client and one node will be set as a server. So what we do here, we create a simple UDP echo server. So one node will be simply a server that receives an UDP packet and echoes it or replies with an UDP packet. And also a client or a node sends an UDP packet and also replies the exact same thing when received. So we create a UDP server and also a UDP client. And we also tell them so when the application will start and when it will stop. And also for the client, we set some of their attributes like how many packets it is going to send, that is set by the max packets. Then also after how long the packets will be generated and sent. That means the interval. And also the packet size. So how long or how large each packet will be. Then we start the client and server, and we also define when the client app will start and when the client app will stop. And finally, we run the simulation, and when the simulation is done running, we destroy or clean the simulation. So, uh, so this is the basic code that is working here, and the output is like that. So if we see the output, it makes sense that at a particular time, the client sends a packet of 1024 bytes to a server or a different node. So we define the packet size of 1024 here. See, so a 1024 byte packet is going to a particular node or the server. Then the exact same thing is echoed back or deployed by the other node. So sending and receiving both are logged here. So this is the basic simulation that is being run here. So now, if we want to visualize our simulation, what is happening here? So what we can do is create an animation of the network. So to do this, what we can do is what we can do is create our add some line to our first.py. So we have copied the first.py to the scratch folder where we will do our experiments. So if we open it, we will see that there are a couple of lines. So at first we can add this animation. So animation, the line for animation. So this line ns.netanim.animation interface first.xml, it will generate a first.xml file that contains the animation script or the script for the animator. Okay, so if we run it, we will get a first.xml. So if we run it, so to run it, we just give first.py. So it will run and it will generate a first.xml after running. So we will expect the same exact output. So we'll see that the same exact output is given, and we will see a first.xml file will be generated. See, a first.xml file is generated. Now, to visualize it, we need a software called NetAnim. NetAnim comes bundled with ns3. To install NetAnim, we also need some prerequisites. So NetAnim, to install it, the prerequisites are the Qt base 5. So after installing these prerequisites, we can just run the qmake netanim.pro and make it will build the NetAnim. So after building, we can simply run the NetAnim. So this folder contains the NetAnim, and after running the NetAnim, we'll see this kind of interface. So this is the NetAnim interface, and we can open the XML file inside it. So if we open the XML file inside it, so we can the open file and select the XML file, and you will see that a particular network is being created here. It is visualized. So it is a grid, and it contains two nodes, one here and another one is here. So we can just run the simulation here and see what is happening here. So if we use the play button, we see that a packet is being sent from this node to this node, and also it is deployed back to the previous node. So as our simulation does basically only these two things, our animation also contains these two things, and it is very small. So we can now visualize our networking events using NetAnim. Also, we can collect some trace files. So we can collect pcap traces of our net simulation. To do this, we can add some extra lines of code in our simulation scripts. So for example, we can use the point-to-point dot enable pkapall. Okay, and first. So what does it do? It, it is basically it is basically listens for the networking events for all of our nodes. So it will create two pk files for each of the two nodes. So if we run it, so as we have already run it, we can see that there are two pk files generated for each of our nodes, one for our node 0 and one for our node 1. So if we open one of it, we'll see that we have sent from 10.1.1.1 to 10.1.1.2 an UDP packet and also received from 10.1.1.2. So if we see the headers for this, we can see that 1024 bytes of data as we have configured in our simulation, and also the frame and point-to-point protocol, that means the data link layer protocol and also the network layer protocol, the IPv4. And also, as we have used UDP, the transport layer protocol is UDP here. So we can trace and exactly see what is going on here using the pcaps. So what we have learned is that we can visualize our simulation, collect some traces of our networking events, and analyze our networking performance. So this is a very basic introduction to ns3. Thank you.